Hello, today we start designing PD controller using root locus. Now we have an example here. So we have a unity feedback system with plant and a controller. So plant dynamics is a second order with 1 divided by s into s plus 2, and controller is k1 ks2. So this is a PD controller. So we have design specification that overshoot must be less than 4.32%, and settling time with 2% specification must be less than 2 seconds. Now if I look at the root locus here, so we have two poles here, at one is at 0, other is at -2, and this is the graph. So we have to meet this specification. So apparently when we have to change the transient response, then we use the PD control. Now we will calculate the dominant closed loop poles using the specification to identify the closed loop pole locations for design purpose. Now so we start solution here. The solution is with maximum overshoot is 0.0432. now from here we use formula to calculate the zeta, and zeta formula is natural log square of np whole divided by pi square plus natural log square of np. Now if I plug in the values, so what I get here, natural log square of 0.0432. Similarly we have pi square, then we have a natural log square of 0.0432. now when I solve it, now zeta become, after calculation, is 0.707. so this is the zeta value. Now next thing, I use the settling time. So I know that settling time with 2% can be written as 4 divided by omega d. Now from here omega d becomes 4 divided by 2, that is 2. So this is omega d. This is the real part of the closed loop dominant poles which we are looking. Now next thing, we have to find the omega d. Omega d is sigma d tan theta of cos inverse of zeta, that we already calculated. Just plug in the values, that is 2 tan of cos inverse 0.707. if I calculate the values, now omega d becomes 2. So now dominant closed loop poles S1 S2 is equal to minus sigma d plus minus j omega d. Now from here S1 S2 becomes minus 2 plus minus 2j. Now we have to use the design point. Now design point that we have to choose is P, that is equal to minus 2 plus 2j. Now this is the basic thing we normally do for all type of designs up till now. Now from here we have to because we have to do the transient improve the transient response. For that we have to use a characteristic equation. If you remember, that was del of s, that is equal to 1 plus gc of s gp of s, okay, equal to 0. Now from here if I plug in the values, so it becomes 1 plus k1 plus k2s whole divided by s into s plus 2 is equal to 0. Now from this equation we have to use two criterion. One is the angle criteria. So angle criteria says that the angle of k1 plus k2s whole divided by s into s plus 2 must be equal to 1 minus 180 degree. Okay, so for our simplicity I just reshape here. What I did, I just say angle of, if I take k1 out, sorry, k2 out, it is easily look at the 0 location, that is k1 divided by k2 whole divided by s into s plus 2 must be equal to minus 180 degree. Okay, now if I plot here quickly, so we have point here, this is the poles minus 2, so the point is somewhere here. This is the P point, that is my 2j, that is, this is the P point, that is 2 plus 2j design point. So to calculate the angle, if I write like this, so this I call it as phi 1, this one I call it as phi 2. So the idea is to find out the location of the 0 here, where I have to put this 0. Okay, this is the location ZP, that is actually equal to location of this ratio, that k1 divided by k2. So I have to find this one. Okay, now I use the angle. So if I plug in the values, so what I know from here, that angle of PD, then we have a minus of phi 1 minus of phi 2 must be equal to minus 180 degree. Now how to calculate phi 1 here? So phi 1 here, if you look here, this is there are different way of calculating this phi 1. So easiest one is if I take this as an angle, so this angle is actually, the whole angle is 180 minus this angle gives me phi 1. So I say the 180 degree minus tan inverse, look for this angle, so this is base, this is my perpendicular, so we have to divide perpendicular by base, that is 2 divided by 2. So from here it becomes 135 degree. This is one way of doing it. Another way is if I take this as a 90 and take this as a triangle, I can solve it, I get the same result. Okay, now move to phi 2. Now for phi 2, this is the phi 2. Again, this how to calculate this angle? So it's very easy. Tan inverse of perpendicular is 2 divided by 2 minus 2. Okay, so because this is so this becomes 90 degree. Now it is obviously very easy to calculate. Now we have to find this ID. I don't know the angle here that will give me the desired result. So if I plug in the values here, so it becomes PD is equal to minus 180 degree, so plus phi 1 and plus phi 2. If I put values here, minus 180 degree, now because it's plus, so we have plus 135 degree and plus 90 degree. So when I solve it, so phi PD it becomes 45 degree. So this is what we get here. Now okay, now if I use the formula, for example, if I take this as a triangle and I say this is the angle and this is the base, so this means that you have to 2 minus ZT, and this is the height is again 2. So I write the formula here. I say that phi PD can be calculated as tan inverse of perpendicular is 2 here, but the base is 2 minus, sorry, sorry, this is Z, not 2, because this is the one, the higher magnitude, so we have ZPD minus 2. Okay, so to solve this we get it. Now phi d is 45, so if we plug in the values, we have to calculate tan of 45 is equal to 2 divided by ZPD minus 2. Now solving this, what I get here, this is 1. Now from here ZPD equal to 4. So this is calculated at 4 location here. So this means that ZPD is equal to 4, or actually ZPD is equal to ratio of K1 divided by K2, that is equal to 4. Now the controller that we come up till now is G of S is equal to K2. We know the location of 0, that is Z plus. Now we have to find this K2. Now we use the magnitude criteria. If you remember, what was the magnitude criteria? Magnitude criteria was magnitude of K2S plus 4 into S plus 2 must be equal to 1. This was the criteria, but we have to evaluate at design point. So to do it quickly, we say that okay, we can do a little manipulation from here. We can write it that K2 is equal to S minus S into S plus 2 divided by S plus 4. Now take the magnitude and solve the problem. Now from here I have to take the magnitude at S equal to P, at S equal to P. So now I rewrite K2 S equal to minus, if you remember, P was minus 2 plus 2j. Now plug in the values quickly, so it becomes minus 2 plus 2j, and do a little manipulation, it becomes 2j. Now divided by, if I do a little manipulation here again, it becomes 2 plus 2j. Take the magnitude. Now when I do that, K2 become minus 2 square plus 2 square under the root. Okay, now again 2 square divided by 2 square plus 2 square. These two cancel, becomes 2. So we know that K2 is 2. Now we already know that K1 divided by K2 is equal to 4. Now from here K1 is equal to 8. Now the controller that we designed for PD is quickly known as 8 plus 8 plus 2. Yes, okay. So this is our controller, PD controller that we designed for. So I stop here. This is example, just do it and you will understand how to solve this problem. Thank you.